This is a collection of how many numbers in this expression. How many numbers is there? 2, huh? It's 2 and 7. So go to write 2 numbers. How many variables? 2, huh? X and Y, there's 2 variables. Don't put 2 variables. How many operations?
2.
Well, I'm getting all kinds of crazy answers.
3.
Nava, give me the 3.
Multiply.
Where? I'll see multiplication where?
When you put the x
Uh-huh.
and the plus.
That's multiplication?
So the 2 and the x is multiplication.
Right, so I asked you what the multiplication is. So it's 2x. So this means 2 times x. So there's multiplication, there's adding, there's the second operation, and then look at, this is division. A fraction bar means divide, so there's 3 operations. Go write 3 operations. X plus y. 2x plus y. We're good? Talk to me. Variables are letters that stand for a number, like X, Y, Z, A, B, C. Okay? So if you forgot what variables are, maybe underneath here, put X, Y, Z's. Okay? So any collection, you can think of one off the top of your head right now, and you are going to do that with your Seesaw Snapchat activity in a little while. You're going to make one off the top of your head. Yours is going to be a lot more bigger than mine and all elaborate and crazy and funky and weird. As long as it has numbers, variables, and operations, you're good to go. And you're going to describe to me how many numbers you have, how many variables, and how many operations. It is. It's very easy. I'm not trying to kill you here. That'll be for later. Just kidding. Thank you. So we know what an expression is. Next word. The next word is a term. A term. An expression with only multiplication as its operation, or a number by itself. Which would be called a constant. A number by itself without any variable is called a constant. So you might have to cram, and there's no space I gave you there. I apologize. They'll be working. An expression with only multiplication as its operation, or a number by itself. A number by itself, the fancy schmancy word, is called a constant. Example. Can someone give me an expression with only multiplication going on? In other words, give me a collection of numbers, variables, and operations where only multiplication is going on. Burns, give me one. Yeah, hit it.
2 times 4 inside of like the parentheses. And the 16.
That's a term. That's a term, ladies and gents. Right, Shem? This is a term because it has 3 numbers, but the only operation in town, the only operation that exists is multiplication. 2 times 4, and then whatever that is times 6. That's only one term, believe it or not. We're going to put one term. Last word, yeah. Let's do one more example, though. Can someone think of a term with a variable in it? Someone besides Via. Nava, hit it.
2x.
Perfect. Perfect. There it is. That's a term. Why is it a term? Well, it's an expression. It's a collection of numbers, variables, and operations. And the only operation going on is multiplication. It's just multiplication. 2 times x. One term. Yeah, we're rocking and rolling now. I lied. One more example. I'll put in green. Last example. So I'm just throwing examples out, just mishmash here. Or let me talk, please. How many terms would this one be? Negative 8 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, U, X, Y, Z. How many terms is that?
A lot.
No, it's one term. Why?
Only multiplication.
Be more specific.
Operation.
Only multiplication going on. That's one term, believe it or not. A lot of variables, no doubt, but that's only one term. Because it's an expression, look at it, it's an expression, it's a collection of numbers, variables, and operations. With only multiplication as its operation. So this is all one term, believe it or not. So I'm trying to drive home the concept of a term. It's only multiplication. Now, go ahead.
So let's just say, I know there's not gonna be a problem like that ever, I think. But like, let's just say like, if they do supply us with the inputs for every single letter right there.
Variable, yeah, every variable.
How would that work out? Like, do you just multiply it from A all the way to
Right, from left to right.
left to right?
Okay, now you're ready to understand the paragraph above on the note guide. Okay. By the way, next to the word term on your notes, above or below, side, right or left, write the word monomial. You guys remember in English class, a synonym is a word that means the same thing?
Yeah.
So a term and a monomial mean the same thing. Term, monomials mean the same thing. Now, let's read the paragraph on top. Polynomials. Poly means many. Like Cal Poly Pomona, that means polytechnic. Many technical disciplines are taught at Cal Poly. A polynomial is a monomial. Remember, monomial just means a term. Or a sum of monomials. Each monomial is called a term of the polynomial. A polynomial with two terms is a binomial. Duh, bi means two. A polynomial with three terms is a trinomial. Look at the examples. Two terms. Look at that's one term. It's only multiplication going on. And here, that's just a number by itself. Remember, look at the way I define monomial. Or a number by itself, which is a constant. So look at this is a binomial here, because it's two terms. Here's a trinomial, three terms. 1, 2, 3. Trinomial. Anything past a trinomial, we just call it polynomial. So if you have a polynomial with four terms, you just call it a polynomial, four-term polynomial. A polynomial with five terms is five-term polynomial. Let's keep reading. The degree of a polynomial is the greatest degree of its terms, which means the highest exponent. So look at the terms here. This term, this term, this term, and this term. Which one has the highest exponent? Well, 2x to the third power has the highest exponent. So we call that the degree of the polynomial. So it's there for you. You don't have to write anything down. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. Look at how it's written. The highest exponent is 3, second highest is 2, third highest is 1. Remember, if it's not there, it's automatically a 1. And then no exponents for any variables. So we call this standard form if it's written from highest to lowest exponent. When you write a polynomial in standard form, the coefficient of the first term is a leading coefficient. Leading coefficient right here. It's the number in front of the variable. It's called the coefficient. We call this the leading coefficient because it's the one right in front. It's the coefficient of the variable that has the highest exponent. We call it the leading coefficient. It's right there for you on your note guide. Go ahead and flip the page. Flip the page. Actually, not flip the page. We're on number 1. My bad. I don't have a copy in front of me, so we're on the bottom now. Find the degree of a monomial. So that's a monomial because it's only one term. What would be the degree of it? What would be the degree of it? Looking at the word degree on your note guide, what would be the degree here? 1. If you look at the exponent of a variable, it's a 1, so this would be degree 1. I'm going to write degree 1. That's it. Just look at the highest exponent. Garcia, you with me? Just check it. W. That's one term. Because look at, there's a 1 in front of it, even though we don't write it, it's always understood to be there. So that's one term, and it's raised to the 1 power, so this is also degree 1. I'm just going to put 1. I'm not going to write degree 8 times here.
Can you put like D1 like that?
That's fine. Here, the degree, there's no variable next to this term, and that means that there's a degree of 0. If you have no variable with no exponent, it's a degree 0. Look at number 4. What's the exponents of the variables there? 1. So you look at the highest exponent of a variable. So that's degree 1. Highest exponent for number 5? 2. So it's a degree 2. Highest exponent here. That's the coefficient. We're looking at exponents. So this would be degree 3 because the highest exponent is 3. Get in the hang of this. Again, degree 3. Look for the highest exponent of a variable. No variables, degree 0. Moving right along. Almost done. You guys doing good. Want to flip the page? Nine through 12. There's 3 missions. Write it in standard form. That's the first mission. Identify the degree. That's your second mission. Leading coefficient. So let's see. Degree and leading coefficient. Actually the second and third mission. And then classify the polynomial by the number of terms. So that's actually 4 missions. We'll do 9 to 12 together. Here we go. Write the polynomial in standard form. Is the highest exponent written first? So let's rewrite this polynomial. Watch this. 3x squared plus, okay, that's the highest exponent, so I put this term first. The next highest exponent is a 1, so that's going to be plus x plus 5. There's standard form. There's mission number 1. Right. We call that descending order, so the highest to the lowest. So highest, lowest. All right, identify the degree. So I'll put degree. The degree is, what's the highest exponent? 2, so this would be a degree 2. Leading coefficient, I'll put LC for leading coefficient. What's the number in front of the highest numbered variable? 3, so 3 would be the leading coefficient. Then classify the polynomial by the number of terms. How many terms is in here? How many terms do we got? 3, so this would be a trinomial. So there's 4 missions there. Standard form, the degree, the leading coefficient, and then the name. We classified it. This is a trinomial. Number 10. Radical 5 y. Let's put it in standard form. It already is in standard form. Let's put radical 5y. That's standard form. There's no other terms. The degree. What's the degree here? The degree 1. Because look at the exponent of the variable is a 1, so it's degree 1. Leading coefficient? Radical 5 is your leading coefficient. And how many terms is this? Is it 1 or 2 terms? 1 term, because only multiplication going on. Square root of 5 times y. There's a multiplication going on. So it's a monomial. Mono means 1. 1 term. We're rocking and rolling. Standard form. Is it in standard form, number 11?
No.
No. 6x to the 8th has to come first for it to be in standard form. Then plus 3x to the 5th. What's the degree? 8. Highest exponent. Leading coefficient? 6. What's the name of it? Binomial. It's 2 terms. Binomial. Classifying means put into a group. So far, so good. Bird, you with me? All right. You're writing this down, right? Birds, is it standard form right now? Number 12? Uh-oh. B, is it in standard form? Is it in standard form, number 12? What should go first? Thank you. F to the 4th. This is a positive f squared minus 2f. Right, Ramirez? I got the floor right now. Ramirez, what's the degree of that puppy, number 12? Donuts, help him out. 4. Highest exponent's the degree.
3.
Right? So the degree is always the highest exponent. So this would be a polynomial degree 4. What would be the leading coefficient? Nice. The coefficient of f to the 4th, the number in front of f is always a 1. If there's nothing written there, it's always understood to be 1. So the leading coefficient is 1. Trinomial. We're rocking and rolling. Last 2 examples are done for now. Uh-oh, we're going to start adding polynomials now. We're going to add a binomial and another binomial. We'll add a binomial, another binomial. Let's add these puppies. It's not that hard. Some of you may have seen this before. Talk to me, Nana. Go ahead. What's the question?
I said even though it says add, like, since it's a -4, that means it, like, it's 2, like 2x.
Right, so what we're going to do is here, write this down. We're going to combine like terms. Combine like terms. You know what a term is now? We defined terms about 15 minutes ago. A term is an expression with only multiplication going on, or a number by itself. We'll combine like terms. -4x plus 6x. Awesome. Again, we deal with the coefficients. -4 plus a 6 will be a positive 2x. 9 plus a -14, -5. You can put -5 or plus -5. It means the same thing. Done. We added a binomial with another binomial. It resulted in the binomial. Crazy, crazy, crazy. Questions? Last one. One more time?
we'll take this up after we evaluate terms? Or do we have to start?
I'm sorry, you want to mention one more time? You
We
want to
have to
take?
say like the degree LC.
No. If they ask for the degree, then you can say it. But right here, just find the sum. We just added them up.
Actually, that's.
Let's do number 14 together. Excuse me, I got the floor still. Thank you. Binomial plus another binomial. Negative 3a, 7a. Negative 3 plus 7 is going to be a 4. Positive 4a, just attach the variables. Negative 2 plus a 5 is a plus 3. We're rocking and rolling. Hit it.
I have a question on, is, like a problem like that, is it going to be like division? In the moment, like it's just say like,
We're not going to get into division in here. No. We'll get into adding. We're going to get into subtracting later on today. And we'll get into multiplication later on today. So we're going to do adding polynomials, subtracting polynomials, and multiplying polynomials by the time the day is ended today. Okay. Watch this. Remember when I made up my own expression off the top of my head? You are now going to do that on your own with Seesaw. You get a piece of paper, you make up any expression you dang want. You want 5 variables, knock yourself out. You want 1 variable, knock yourself out. You want 10 variables, knock yourself out. You want 8 numbers, knock yourself out. But it's got to have a collection of numbers, variables, and operations. You're going to post that puppy, and you're going to describe it with your voice. And you're going to give it to me for your last step. That doesn't mean when you're done, you just don't do anything. You got to go on your assignments after, but everyone goes on their Seesaw. Grab your Chromebooks. Most of you already have them. Let's get big busy. The Seesaw is not an assignment, it's an activity.